Hi, this is Dave Johnson with another edition of Math Off Topics. Today, I want to start a three-part series on conjugates. So, the first video will be square root conjugates. The second video will be part two, cube root conjugates. And the third video, part three, will be trig conjugates. And so, I'm not going to talk about complex conjugates because I think that's been adequately covered before, and I'm sure you've seen that in either your college algebra or your pre-calculus class. So, and I want to do these problems in the context of limits in a Calculus 1 course. So hopefully this will be helpful for you. So let's get into it. I have in mind a couple of limits that I want to do. The first one on the left is maybe the easier one, and we'll do that fairly quickly. The right one, maybe a little bit trickier, but not much. So let me just copy this limit. And first, I want to point out that when you plug in x=0, you get an indeterminate form. So if x is 0, x squared is 0. So you get the square root of 9, which is 3. So upstairs you get 3 minus 3, which is 0. And downstairs, of course, you get 0. So 0 over 0. And anytime you get 0 over 0, especially when you're working limits, you know your work is not done. You need to do more algebra or something to get rid of the indeterminacy in your limit. So that's what we're going to do next. Is we're going to try to do some algebraic manipulation that will get rid of the indeterminacy. And what I'm suggesting is that the best way to do that is to think of this as uh, a conjugate, in this case, a square root conjugate. Now, let's think about how we might approach this. By the way, you don't want to memorize how to do problems as much as you want to understand the approach in how to do problems. Memorization is great in certain situations, but when you're confronted with a problem, every problem is going to look different. And so if you're just memorizing how to do problems, that's going to be hard to sustain going forward. So I think of this square root of x squared plus 9 as some number, call it a, and we're subtracting something, in this case a 3 in the numerator, and let's call that b. And so we've got an a minus b, and so this is a minus b upstairs. And what is the idea of the conjugate? Well, if we multiply it by a plus b, then we'll end up with a squared minus b squared, right? So a minus b times a plus b is equal to a squared minus b squared. And the whole idea behind squaring the a and squaring the b, if you square the a, you get rid of the radical. And that's exactly what you want to do. You want to get rid of this radical somehow. It's not that radicals are bad, and there are other ways that you might be able to do this problem. But using this method, what you're going to end up doing is getting rid of the radical, and hopefully other nice things happen. So let me just kind of put this away a little bit, make it a little smaller. And so I've got my a minus b upstairs. So we're going to multiply top and bottom by a plus b. Well, the a plus b is going to be the square root of x squared plus 9 plus 3, that's the a plus b, divided by, and then a plus b downstairs, which is still the square root of x squared plus 9 plus 3. Okay, so in this factor, which is a 1, by the way, um, square root of x squared plus 9 plus 3 divided by x squared, square root of x squared plus 9 plus 3, that's 1, multiplying the function that we're taking the limit of by 1. So we're not changing the value of the limit. Okay, and this is your a plus b. And so a minus b times a plus b is what? Well, We multiply it out, we get, so limit as x goes to 0. Always carry your limit with you. That reminds you that you're doing a limit. And if you see anything that you can take advantage of limit theorems or whatever, the limit is right there. You know what you're doing. You don't get lost in the weeds just because you've forgotten that you're doing a limit. So a minus b times a plus b is a squared. Well, the square root of x squared plus 9 squared is x squared plus 9. And then minus b squared, well, 3 squared is 9. And then divide by your x squared. That hasn't changed. Except that you also have your factor. You don't want to forget that. X squared plus 9. And that plus 3 cannot go under the radical, of course. So plus 3. And don't forget your parentheses. Let me move this over just a little bit. Okay. Keep things neat as much as possible. And okay. Now, the 9s cancel, and that was one of the nice things that happens in this situation. Because when you did the square of x squared plus 9, the radical goes away and you get x squared plus 9, and then you're going to subtract the 9 from that. Okay, so I can rewrite this as limit as x goes to 0 of x squared upstairs divided by the x squared times the square root of x squared plus 9 plus 3 downstairs. Now we still have an indeterminate form, right? If you plug 0 in for x, you get a 0 upstairs, and you obviously get a 0 downstairs. But what's nice about this is now I can cancel the x squareds. And so we get limit as x goes to 0 of 1 divided by, and then the square root of x squared plus 9 plus 3. So this is no longer indeterminate. So we can plug the x equals 0 in, and what do we get? We get 1 over, well, the square root of 9 is 3. 3 plus 3 is 6. And so that's our answer. So our first limit is 1/6. Okay. Now let's go ahead and do the second limit. Let me just copy it from up here. Copy. Now, this one's a little different because it's not going to be a 0 divided by 0 in determinate form. In fact, we're taking the limit as x goes to positive infinity. So we're going to get actually, if x is infinity, then that term is going to be infinity. This term is also going to be infinity. So infinity minus infinity. Now you can't say that's 0. Infinity minus infinity is an indeterminate form. And plus we have an infinity here. So it's like, what do we do? Well, I'm seeing that radical there. And so I think what we could do is sort of the same thing. Multiply top and bottom by the conjugate. And you say, well, wait a minute, there's no bottom. Well, think of there being a bottom. You can put a 1 down here if you want. And then we're going to multiply by the conjugate, the square root conjugate of the term, the two terms in the parentheses. And again, think of this as your A and this is your B. Okay, so we get times 3x plus the square root of 9x squared plus 1 divided by this 3x plus the square root of 9x squared plus 1. Okay. Rewriting, we get limit as x goes to infinity. The 4x doesn't change, so it's still there. This, of course, is your a plus b. So a minus b times a plus b is a squared minus b squared. So you're going to get, so 3x squared is 9x squared. And then minus the quantity. Now you got to be a little careful, put that in parentheses. You're going to square the radical, so you're going to get 9x squared plus 1 because you're squaring the radical, so the radical goes away. And then downstairs, you still have what you wrote before, the 1 times 3x plus the square root of 9x squared plus 1. Now, one thing that's nice about this is that you can see the 9x squareds are going to cancel. So let me rewrite this limit as x approaches infinity of 4x times, now let me go ahead and distribute the minus sign, so we get 9x squared minus 9x squared minus 1 divide by 3x plus the square root of 9x squared plus 1. And so the 9x squareds cancel. You get a minus 1 inside the parentheses, so I can rewrite that. I can bring that minus 1 out. So minus limit as x approaches infinity of 4x divided by 3x plus the square root of 9x squared plus 1. Now, this gets a little bit, you might say, well, wait a minute, I can't cancel the x's, but I can factor an x out. In fact, let me rewrite this. So this is going to be minus the limit as x goes to infinity. Now I'm going to leave the 4x the same upstairs. Downstairs, I'm going to write this as 3x plus, and I want to take let's do this off to the side, the square root of 9x squared plus 1, I'm going to factor out that's really 3x quantity squared plus 1, so I can write this as 3x squared times 1 plus 1 over 3x squared. That's all under the radical. Okay, so the square root of 3x squared is 3x, so this is equal to 3x times the radical square root of 1 plus 1 over 3x squared. And so let me write that here. So this is 3x times the square root of 1 plus 1 over 3x squared. Okay. Well, I can factor out a 3x here, so we get, let me rewrite the whole thing, minus limit as x goes to infinity, 4x upstairs, downstairs 3x times, well, 1 plus, and then the square root of 1 plus 1 over 3x squared. Okay. To avoid a little confusion, let's move this off to make this a little smaller so it doesn't get in the way. And now I can see that we can cancel this x with this x, and I can bring the 4/3 outside, so we get minus 4/3 times the limit of 1 over 1 plus the square root of 1 plus 1 over 3x squared. Now you say, well, this looks complicated, but it's no longer a determinant. And if I plug in, and this is, of course, as x goes to infinity, if x is infinity, then that 1 over 3x goes to 0. And when you square 0, you get 0. And so you've got this whole square root becomes square root of 1, which is just 1. So we get minus 4/3 times the limit as x goes to infinity of 1 over 1 plus 1, but that's just 1/2. And so we get our final result, negative 4 over 3 times 2, which is 6, or negative 2/3. And that's the answer. So um, obviously there was a little bit more work involved in this one because once we got the uh, once we applied the square root conjugate, we still had to figure out what to do with that radical that was in the denominator. And you're going to see problems like this in your homework in calculus. So study this example carefully. Make sure you understand every step. If you have questions, you're welcome to leave them in the comments, and I'll do my best to answer them. So I hope this was helpful. Uh, if you enjoyed the video, if you found it helpful, subscribe to my channel and give this video a like. I appreciate it. Thank you very much. See you next time for part 2.